Hi, welcome to our second video on visual processing. In the last video, we talked about basic parts of the eye and their function, and we talked a little bit about sensation, perception, and transduction. So in this video, to be a little bit shorter, we're going to talk about how the eye transduces physical energy of light into a neural impulse. Make sure you have your notes available and make sure you follow along and pause and rewind as necessary. So let's get started. So as we talk about visual transduction, remember this is a very important term in this unit. You really have to know this term and be able to explain it. This is the process by which sensory signals or stimulus energy from the outside world are transformed, transferred, or translated into a neural impulse that the brain can read and make sense of. So we've seen this cross-section of a retina before. Remember, we have light is still a stimulus energy coming from the left side of our visual scene. And then we have a cross-section of the retina here with the three layers of cells, ganglion cells, bipolar cells, which are not photosensitive. And then we have our rods and cones in back. And then here we have a more magnified cross-section with rods in the back where transduction takes place, bipolar cells, and then the neural impulse goes to ganglion cells. Let's take a quick look here. Remember, our photosensitive receptor cells are the only cells in our eye that respond to light energy. These are the rods. They're located in the periphery, or at least outside of the fovea for night vision, detection of edges. There's about 120 million in each eye, and they're located, again, in the back of the retina. And then we have our cones, which are also photosensitive receptor cells, that about 6 or 7 million in each eye, located mostly densely packed in the fovea, mostly sensitive to either red, blue, or green, long, medium, or short wavelengths of light. And they're also responsible for visual acuity. You should ask yourself why they are responsible for visual acuity and how that relates to the bipolar cells. Okay, so we're going to move on here and we'll take a look at just a section of one photoreceptor cell, one bipolar cell, and then one ganglion cell. And you'll probably notice from this diagram right here that this photoreceptor cell, whoops, that wasn't good. This photoreceptor cell right here must be a cone because it has its own bipolar cell and it must be located in the fovea. So as we look here and we look at part of the function of our bipolar cells, remember bipolar cells are not photosensitive. They are located between photoreceptor cells and ganglion cells. And their task really is to directly or indirectly transmit signals from our photoreceptor cells, rods and cones, gather that information and send it along to the ganglion cells. The ganglion cells then start initial visual processing, but their primary purpose is to send all of our signals from our retina out of the eye into the brain to the thalamus. Well, there's about 1 million ganglion cells in each eye, and their axons here transfer information directly to the brain. Now remember, our photoreceptor cells here, they have a chemical reaction to light, to light energy, and the chemicals trigger, that chemical change triggers an electric current called an action potential that then sends the signal across that synapse to the next cell, bipolar cell. They send a neural impulse. They have an action potential and send a neural impulse to the ganglion cell, and the ganglion cell then sends their action potential signal to the brain in the thalamus. Now again, a little review of the eye. You should be able to name the parts in order that light travels past before information gets to the retina where transduction takes place. Now remember the fovea, you need to be able to describe that, where most of our color sensitive cells are located. Those are called cones. Remember that the ganglion cells in the retina all gather together and send their signals out the back of the eye along the optic nerve. So the ganglion cell axons form the optic nerve, and those signals leave in what's called the blind spot, or also known as the optic disc. It's a place in the retina where there are no photoreceptor cells. It's where the ganglion cells leave the eye, and also veins enter the eye to nourish the eye. Now, this is really important, the transduction pathway. So you should know this diagram fairly well. We'll talk about it a little bit here. We're going to talk about the optic chiasm. That is a point near the base of the brain. So we're looking at the brain from the top down. This is, from the bottom up. This is where signals from each eye, some ganglion fibers from each eye cross over and travel to the opposite side of the brain. And we'll talk about that right here. Remember, information traveling from the left side of each eye is going to end up on the left side of the brain and vice versa. So let's follow the pathway. And assuming light travels in a straight line, and if you're looking straight ahead, light that hits the left side of each of your eye, if we follow that color dark green, is going to travel to the left side of the brain from each eye. Now it travels directly to a part of the thalamus called the lateral geniculate nucleus, the LGN, which is a part of the thalamus. And then information from the thalamus, which relays information from our senses except smell, is going to travel to the occipital lobe for primary visual processing. And that is located in the back of the brain. And that's where we construct our visual scene so we can detect and perceive it. So vice versa is true. So information coming from the right side travels to the right side of each eye, from the left field of vision, so over here, travels to the right side of each eye, and then that information stays on the right side of the brain, to the LGN and to the occipital lobe. So I would practice that once or twice, following that pathway from retina left to LGN thalamus left to occipital lobe left. And then information is combined and then top-down processing takes place. So I would review and let me know if you have any questions, and we'll talk about some of that information in class tomorrow, like the blind spot. We'll do a blind spot test and so forth. So thanks for listening, and we'll talk soon.